Welcome back, dear students. Today we'll start a new chapter, and the name of the chapter is Rational and Irrational Numbers. Okay, so as the name itself suggests, we are going to deal with rational and irrational numbers in this particular chapter. So first and foremost, let's understand what is the meaning of rational number. Okay, so rational number is basically a fraction. Okay, and if I ask you how do you represent a fraction, you say I represent a fraction in this way, isn't it? Okay, something by something. Now in this case, what you need to remember is the first thing is this denominator. This is called numerator, this is called denominator. So denominators should not be equals to 0. Okay, that's the very important thing that you need to remember. Okay, and one more thing is number 2, that is if you factorize a and b, okay, if you factorize a and b, there should not be any common factor. Okay, there should not be any common factor. So only common factor between a and b is 1. Okay, so apart from 1, you cannot have any other common factor. That means you cannot have 2 as a factor of this and 2 as a factor of this as well. Okay, see, if 2 is a factor of this, the factor of b cannot be 2. Okay, so that's what is the meaning of this particular sentence, that is only common factor between a and b, that is numerator and denominator, is 1. So if this happens, this is also known as a and b are co-prime. Okay, so if somebody asks you a and b are co-prime, what does this mean? Then you have to say that the only common factors between a and b are 1. Okay, that's the meaning of co-prime. So if this thing happens, then this type of fraction is known as rational numbers. Now let me give you some examples here. So examples, let me give you 3 by 7. Okay, now when you factorize 3, see, when you factorize 3, you get 3 into 1, that's all, right? And when you factorize 7, you get 7 into 1. See, what is the common factor here? Here we get 1, and here also we have 1. So that means 1 is common to both, isn't it? So 1 is the only common factor. So that's why 3 by 7 becomes your rational number. Okay, so for example, let me take 5 by 14. Let's take this. Now if I ask you to factorize 5, you can write this as only 5 into 1. Okay, and if I ask you to factorize 14, you can write this as 2 into 7 into 1. See, we have only, what is the common factor? Here we have 1, here also we have 1. So only common factor is 1 here. So that's why 5 by 14 is also a rational number. Similarly, let me give you a few more examples. If I give you 8 by let's say 20. Now if I ask you to factorize this, you can write this as 2 into 2 into 2. And if I ask you to factorize 20, you can write this as 2 into 2 into 5, isn't it? Now in this case, the common factors, see, here we have got 2, here also we have got 2, so common factor is 2. But in this case, you know that you can cancel, isn't it? And you get 2 by 5, isn't it? Now 2 by 5, is there anything common between them? No, right? So that's why we say that this is also, that's 8 by 20, which in turn can be written as 2 by 5, is also a rational number. Okay, so these are the two things that you need to remember when you want to verify whether the number is rational number or not. Okay, so that's all about your rational number. Now let's understand few things, or few very important things that you need to remember. So first is, suppose, okay, so we'll do that whatever I wanted to say here in the next class. Okay, so suppose today we'll take one important topic. Suppose you have got one rational number, for example 2 by 3. Okay, and let's take one more rational number, let's say 7 by 5. Okay, now if I ask you what will be the sum of these two, then your answer will be, see, you have to find the LCM and you do some sort of calculation here, isn't it? Now after calculation, whatever number you get will also be a rational number. That means, in other words, this is rational number, this is rational number, so their sum is going to be a rational number. Okay, so this is the first thing. Similarly, if I ask you, instead of finding sum, find difference, then whatever you get, that will also be a rational number. Similarly, division and multiplication will also give you a rational number. Okay, now, okay, so few more things for revision. So you remember what is natural number? So natural number is natural numbers. Okay, so natural numbers are the numbers like 1, 2, 3, 4, and it continues, right? So next is whole numbers. Whole numbers start with 0, 1, 2, 3, 4, and it continues, right? Now if I ask you what are integers, so integers are the numbers 0 plus minus 1 plus minus 2 plus minus 3. So here if you see, you have only positive numbers, here also positive, but here in integers we include negative numbers as well. You have understood rational numbers, isn't it? Okay, now my question is, are all these numbers natural numbers, a rational number? Yes. You know why? Because you can write this 1 as 1 by 1, isn't it? Now 1 by 1, is it a rational number? Yes. Now 2 can be written as 2 by 1 again. So 2 by 1 is also a rational number. 3 by 1, that is 3, is also a rational number. So that means all the natural numbers are rational numbers. Now what about whole numbers? See, we know that these numbers are rational numbers. Now what about 0? Is 0 a rational number? Let's say, or let's check. So can I write 0 as 0 by 1? Yes. So not only 0 by 1, but you can write anything like 0 by 3, 0 by 4, 0 by 5, anything. Now see, denominator, is this equals to 0? No, right? So that's why we see that 0 is also a rational number. So if 0 is rational number, then obviously this entire thing becomes your rational number. So in other words, whole numbers are also rational numbers. Okay, similarly integers will also be in the rational numbers. Here we see the signs are positive, isn't it? But here you may see that you may get negative also. So that means you may have negative rational numbers as well. Okay, so these are the things that you need to keep in mind. Okay, now one more thing. Suppose if I give you two numbers, let's say A and B. Okay, and let's say A is less than B. Okay, now if I ask you, in between A and B, insert a rational number. Okay, insert a rational number in between A and B. Then how do you do that? You have to first add these two numbers, okay, and divide it by 2, and that particular number will be in between A and B. So this will be the rational number in between two given numbers. Okay, so with this much of introduction, let's start with the exercise on rational and irrational numbers. Okay, so here we have the first exercise 1A. First question is 0 a rational number? So I have already done that. Now number 2 is, are the following statements true or false? Now every whole number is a natural number. Okay, so you know, in whole numbers 0 is also included, but is 0 a natural number? No, right? So that's why the first statement is false. Okay, number 2, every whole number is a rational number. Yes, we have seen that. Yes, so this is true. Every whole number is a rational number. Every integer is a rational number. That also I have spoken already. Yes. Now every rational number is a whole number. Is it true? For example, every rational number, you can take 2 by 3. Okay, so 2 by 3, is this a whole number? No, right? So that's why number 4 is always false. Okay, now Very important question. Let's have a look at question number 3. I'll do question number 3. You'll try question number 4 by yourself. Let's see. Now we have arrange minus 5 by 9, 7 by 12, minus 2 by 3 and 11 by 18 in the ascending order of their magnitudes. Okay, so we'll arrange them in the ascending order of their magnitude. Also find the difference between the largest and the smallest of these rational numbers. Okay, so you need to find the difference, express this difference, whatever difference you get, you have to express that as a decimal fraction correct to one decimal place. Okay, so let's see this particular question. So the given numbers are, so let's see what are the given numbers. Okay, so these are the 4 given rational numbers. Okay, now you have to arrange them in ascending or descending. You have to arrange them in ascending order of their magnitude. Okay, so let's see how to do this. In such case, what you need to do is you need to first find the LCM of the denominators. Okay, so we have, let's do that in rough. So we have 9, 12, 3 and 18 as the denominator. So let's find the LCM. So 3 is a 9, 3 4 is a 12, 3 1 is a 3, 3 6 is a 18, again with 3. Okay, so 3 1 is a 3, 3 2 is a 6, so with 2, so 2 is a 4. Yes, okay, so let's see the LCM. Okay, so LCM of denominators. So let's see what's the LCM. So we have 3 into 3, 9 into 2, 18 into 2 is 36. So LCM is 36. Now what we'll do is we'll multiply each and every rational number by the LCM. Okay, so therefore we have minus 5 by 9 into, so the first rational number into the LCM. Okay, so 9 4 is 36, so minus 5 into 4 is minus 20. Okay, similarly we have 7 by 12 into the LCM, that is 36. So 7 into 3 is 21. Okay, next is minus 2 by 3 into 36. Yes, so this is minus 24. Okay, and we have at last 11 by 18 into the LCM, that is 36. So how much is this? This is 11 into 2 is 22. Okay, so we got these numbers, isn't it? Now if I ask you which is the biggest number, obviously your answer will be this one, positive number, right? So this is largest. Okay, now let's talk about the smallest. Now you might say, okay, so first and foremost, negative numbers are there, means the smallest number is going to be my negative number. Okay, now I have got two negative numbers, one is minus 20, one is minus 24. I hope you are familiar with real number line also. Okay, so for example, if 0 is here, you write 1 2 3 minus 1 minus 2 minus 3, somewhat like this, isn't it? Now all of you know the numbers which are lying to the right are always bigger. For example, 2 is in the right of 1, right? So obviously 2 is greater than 1. Now you see this number minus 1 and minus 2, which one is lying to the right side? Minus 1 is lying to the right side, so that's why this is bigger. Okay, and this is big and this is small number. Okay, so basically your in negative numbers what happens is, if the value of the number is more then the number is small. See, out of 2 and 1, which one is more? 2 is more, right? But because of negative sign it becomes small. Now out of 20 and 24, which one is more? 24 is more, and because of negative sign it becomes small. Okay, so that means the smallest number here is minus 24. Okay, so this is the largest, this is the smallest. Now next smallest is this one, next is this one, and the largest is this one. Yes, so therefore ascending order Okay, so ascending order, how do you write ascending order? You have to write the smallest first. So what is the smallest? Smallest is minus 24, but this minus 24 came from minus 2 by 3, so that's why you have to write minus 2 by 3 first. Next smallest is minus 20, which is a part of minus 5 by 9. Next is 21, which is a part of 7 by 12, and the last one is 11 by 18. Okay, so you know this is smaller than this, isn't it? So that's why you'll write this particular sign. Okay, now the question is saying find the difference between the largest and the smallest. Okay, so this is the largest and the smallest. So difference, so question is asking you to find the difference. So largest is 11 by 18. Difference means minus, so you have to subtract the smallest. Smallest is minus 2 by 3, so minus 2 by 3, that's what we need to do. So let's first open the bracket. So minus into minus becomes plus 2 by 3, right? So you need to add these two fractions. So first you find the LCM, 18 and 3. LCM is 18, so it becomes so divide 18 by 3, you get 6. 6 into 2 is 12. So how much is this? This is 23 by 18. All right, now at last you need to write this difference in decimal form also, correct to one decimal place. So let's see how much is this. So we have 20, we have to divide 23 by 18, so 1 gives you 18, 5 put point here, so you get 50, right? So if I do 3 times, let's see how much do we get. So 3 is a 24 carried over 2, 2 1s are 2. Okay, so I'm sorry, we are doing with 3, right? So if you do with 3, 3 8s are 24 carried over 2, 3 1s are 3 plus 2 54. So you cannot put 3 here, so put 2. So 2 into this is 36, right? Okay, so how much is this? So this is 4 1. So again, due to decimal, we'll put 0. Okay, but here question is saying correct to one decimal place, isn't it? So do we need to go further? No. If they ask you to do 2 decimal place, then you have to put 0 and do further division. Okay, so since they are asking only 1 decimal place, I'll stop with this. Okay, so that's why this is approximately equal to how much? 1.2. So we got our all answers. So ascending order is found. So next is difference is also found, and you have to convert this into 1 decimal place, that is also found. Okay, so you may pause the video and note down your solution. So here we have the next topic, that is the conversion of a rational number into decimal number. So before we do that, let's see the different kinds of decimal numbers. So first is terminating decimal number. I'm sure you all know how to convert a fraction into decimal, isn't it? So for example, 1 by 8, if you convert this into decimal, it becomes 0.125. Okay, so that's all. See, we don't have any problem here. So this is called terminating decimal number. Next is non-terminating decimal number. Now if I ask you to convert 3 by 7 into decimal number, you keep on dividing. Okay, so you get these numbers, so it won't stop. Okay, so that means if the division won't stop, that kind of number is called non-terminating decimal number. Okay, sometimes what happens is when you keep on dividing non-terminating numbers, some set of numbers keeps on repeating. For example, if I ask you convert this 11 by 30 into decimal, you find it to be 0.366666. Basically, so this 6 is repeating here, isn't it? So if some number keeps on repeating, that kind of number is called recurring and non-terminating. So this kind of numbers are called as non-terminating recurring decimal numbers. Okay, now very important formula. If there is a fraction a by b or rational number, and question is asking you to check whether this is terminating or not, then what you need to do is you have to check with the denominator only. That is, if b can be written as 2 to the power m into 5 to the power n, where m and n are whole numbers, then a by b is a terminating decimal fraction. Okay, so in order to understand this well, let's take the question number 5 from exercise 1a, which says, without doing actual division, find which of the following rational numbers have terminating decimal representation. So you are not allowed to do the division here. Okay, so let's see how to do this. So I have taken 5 sub number 1, 2, 3 and directly 8. Okay, so we will just deal with the denominator. Okay, so 16. So can I write 16 as, if you first see, what you need to do is you will factorize 16. So when you factorize 16, you get 2 into 2 into 2 into 2, right? Can I write this as 2 to the power 4? Yes. Now where is 5? Is there any 5? No, but remember, we can write here 5 to the power 0 also, you know, because 5 to the power 0 is how much? It is just 1, isn't it? Now are 4 and 0 whole numbers? Because the powers m and n are whole numbers, right? So are 4 and 0 whole numbers? Yes. So that's why we see that, see, this is b, that is the denominator, is represented in this way, isn't it? That's 2 to the power 4 into 5 to the power 0. So that's why we say that 7 by 16 can be, or is a terminating decimal fraction, is a terminating decimal fraction. So that's how we need to do this kind of sum. Okay, let's say similarly this particular problem. So here you need to, or you have been given 125. So if you factorize this becomes 5 into 5 into 5. Okay, so which is 5 cube, isn't it? Now similarly, can write 2 to the power 0? Yes. So is this number is this number in this format? Yes. So that's why again we say that 3 is also a whole number, 0 is also a whole number. So that's why we say that this is a terminating decimal fraction. Okay, I'm not going to write that. Let's see the next, 9 by 14. So if you factorize 14, you get 2 into 7. This is creating a problem because I need only 2 and 5, right? So because of the presence of 7, this cannot be written as terminating decimal fraction. Okay, so since 14 cannot be, let's write 14 cannot be expressed as 2 to the power m into 5 to the power n, hence 9 by 14 cannot be expressed as terminating decimal fraction. Okay, expressed as terminating decimal fraction. That's what we need to write. Okay, last one is 250. So 250 can be written as, see, first and foremost, I hope you know how to factorize this. So 5 into 5 into 5 into 2, that's what you get. So this is 5 cube into, this is 2 to the power 1, this and this. Yes, so that means 250 can be expressed in this way. So therefore we write 123 by 250 is a terminating decimal fraction. Okay, so that's all for the day. I hope the first exercise was easy. So with this we close for the day. Thank you very much.